Hey guys, I'm back today with the Creality Ender 7 and I want to thank Mech Solutions, that's mechestore.com, for getting this printer into my hands so that I could modify it. Now I've already done 2 videos on this printer. One of them was the general installation and setup of this printer, and the other one was a CR Touch install with the LED ring on the inside. Just kind of increases visibility in there, and obviously the CR Touch does the auto bed leveling. Now if you've been watching other YouTubers with the Ender 7, you might have seen some good reviews and some bad. I've had a very positive experience with this printer overall. I've seen some guys do some pretty dumb things with this printer. One of the guys cut the front of the machine right off so he could see inside better. I think he claims to be a 3D printing nerd or something like that. And I suppose he didn't realize that the plastic cover just comes off. You can unbolt it and just take it off and see inside if you really had to. But regardless, the machine's been a little bit controversial for some people, but I think it has a lot of potential. I've mentioned that in my previous videos, and we're going to be exploring that potential. And so the next modification on this printer that I've done, I designed a triple lead screw setup on this machine, and so they're all synchronized with a single belt system in the bottom with a pulley block, and it supports the what once was cantilevered print bed on this machine, and it changes that whole setup to a very rigid and very well supported setup with linear rods in the front and the back, so it gets rid of the Creality V wheels. And like I said, it moves to a triple lead screw setup, and so the print bed is now very well supported. It will not shake around, and the front end of the print bed is rigid. It's not sagging at all, and it makes the Z layers on this printer come out super consistent and super smooth. So we're gonna take a look at how to install that. And if you guys have an Ender 7 and you're looking to do this exact modification by the end of this video, if you're convinced that it's something for you, I'm launching a website. It's gonna be embracemaking.com, and you're gonna find upgrades like this on that website, plus a bunch of other 3D printing things that you can shop around, buy, and download as well. So check that out. I'll put a link to that in the video description down below as well. So let's get started. And so I'll start by explaining why cantilevered print beds suck for those of you guys who don't already know, and that's because the front edge usually sags. And so you can see how the leveling springs at the back are more tension than the leveling springs at the front, and that's because that front edge is not supported, and therefore it sags. Now the leveling springs make up for that sag, and the print bed can still be leveled, but it's just not very secure and not very stable. Now I haven't had any issues with this while printing on the regular Ender 7 settings, the default speeds, so the quality still comes out really nice on this machine, but as we get going faster, it's going to become more obvious that this thing is shaking around, and we don't want that. So we'll start off by taking a quick look at the 3D mock-up of the Ender 7 that I made, and the first thing that probably stands out to you is some of these red parts here, namely this one at the bottom. This is a pulley block that arranges the belt system that's going to run that triple lead screw setup, and then underneath the print bed you have a few print bed plate supports that guide the print bed along the new linear rods on the side and back of the machine, as well as those 2 new lead screws on the side. And then you have some parts in black. You can see this one here on the side and this one here on this pillar. Those are going to be supporting the linear rods and the lead screws. There are similar parts up at the top and another one at the back of the machine back here to support the tops of the rear rods. So that just kind of gives you a general look at the parts we're going to be using to upgrade this printer and how they're laid out. And so without wasting any more time here, the first thing I'm going to do is move the print bed down to about the 140 millimeter mark, and this is going to give me enough room to work around the print bed to remove it eventually. And before we remove that, the next thing we're going to do is remove any remaining filament left inside of the print head and Bowden tube. So preheat the hot end to about 200 degrees, and then I can just manually pull that filament out, because we're going to be removing the top plate of the printer and we don't want any filament in there getting tangled up. After I've removed the filament, I'm going to go ahead and remove the heated bed connector at the back of the machine, and we're going to be working on taking the heated bed and build plate off now. The build plate can be removed with 4 screws at the back. They should be M4 socket head cap screws. You can easily access the 4 of those from behind. Then you can remove the top plastic cover right at the back of your print bed, and this will expose 8 more M4 socket head cap screws that you can get from the top. And while you're doing this, you're going to want to support the print bed with your hand from underneath, because once those 8 socket head cap screws come off, the print bed will just fall right off. So don't let it drop. Carefully remove the print bed by pulling it out of the front of the machine and putting it somewhere safe. If you plan on doing any build plate modifications, this is a great time to get that done. With the print bed off of the machine, you have full access to it. There are lots of videos online on how to upgrade to spring steel build plates, so I'm not going to get into that in this video here, but I am going to be doing that on this machine. One other weird thing that I noticed when I had the print bed off was that these V-wheels don't always roll so smoothly, and you can definitely see here how they sort of catch and get stuck. It's almost as if these V-wheels have flat spots on them, and I don't know if that is from over tightening them while I was trying to get rid of some of that print bed sag, but something like this could show up as artifacts in your print. I didn't have that experience with this machine, but it's just another reason to get rid of the V-wheels and to go with something a lot more serious like linear rods. So let's get rid of these V-wheels and this bracket once and for all. And to do that, all you need to do is loosen off the front V-wheels enough, and that bracket will come right off of that rear extrusion. So you're going to want to hold the bolt that goes through the V-wheels with a hex key, and then you can just use a regular wrench to loosen off the nylon locking nuts. And like I said, the whole bracket will slip right off the extrusion. At the back of the machine, you can unclip the wiring harness up at the top. Once I unclip mine, you might see a few other wires running down to the base of the machine. These are the wires for the CR Touch that I installed in another video. And in that video, I explained why you can't run them, or at least I couldn't run them, through the connector that goes through that original wiring harness. And so when I take the top plate off of my machine, I will not be able to remove it too far away from the printer. I'll only be able to set it down beside the rest of the printer because of course it will still be attached by these wires. Next, the top of the machine has to come off, and there are 4 M5 socket head cap screws on each extrusion, so each of those pillars. You're going to obviously loosen them, completely remove them, and then the top of the printer will pop right off. Make sure no wires get caught while you're removing the top of your printer, and set it aside somewhere safe. We're going to be messing around with the Z-axis next, so this is a good time to unplug your Z-axis stepper motor. Now we can remove the Z-axis lead screw as well as the coupler, and to do that you're going to want to loosen off the little screws on the coupler, and if those screws are not facing you, you can easily rotate that whole thing by hand now that you've unplugged the Z stepper motor. And with both screws loose, you should be able to wiggle the whole thing right out. Now you can grab the 20-tooth GT2 pulley with the 5mm bore, and you're going to want to make sure that those grub screws are loose. This piece will slip over the Z stepper motor shaft, and it's going to be sitting with the teeth side facing down and the grub screws on the top. Tighten those grub screws down, and you'll notice that there is a flat spot on your Z stepper motor shaft. Try and align one of your grub screws with the flat on the Z stepper motor shaft, and that's going to ensure that that thing will never slip off. And now you can install the original coupler back on top. You'll see one side has the 5mm bore and the top side has the 8mm bore for the lead screw. So 5mm bore side down, and then again tighten just the bottom screw on that coupler so it grabs onto the Z motor shaft. Now we have a little bit of assembly work to do, and if you purchase these parts from me, you'll grab these 3 pieces pictured here. And there's the bottom side, the top side, which I have in my hand right now, and the tensioner, which we're going to be assembling first. To assemble the tensioner, you're just going to need one of the M5 hex head screws. You're going to pop that in through the bottom while putting one of the smooth idler pulleys in the middle, and that's going to hold the idler into place. On the top of the tensioner, you're going to use a washer and a nylon locking nut to hold everything together. Do not over tighten it. You don't want that smooth idler pulley to bind. It should be freewheeling and free spinning by the end of it. Grab the remaining 2 M5 hex head screws, and next you're going to be popping those in through the bottom of this bottom half of the pulley block, and you'll see exactly where the heads will sit inside of that 3D printed piece. And then you can drop 2 more smooth idler pulleys right on top of those M5 screws. Now you can grab the tensioner piece, and you'll see that there is a rectangular cutout window in the bottom of the pulley block, and you're going to put the tensioner with the flat side facing the front of the pulley block, and you're going to put that in that little rectangular window, and now you're going to arrange your belt like so. So you're going to pinch the middle through those two rear idler pulleys. You're going to put that out the side, fold the belt back over top of the idler pulley at the front, and you should be able to slip that around that pulley, and so it comes out the front just like that. So with the belt now sitting like that, you can take the top of the pulley block and it should be able to fit right on top, and there's also a rectangular window in the top of the pulley block where the tensioner will pass through. When you have the top half of the pulley block seated, the tensioner will now slide forward and lock the front into place. At the back, you're going to lock the back into place by putting 2 more washers and 2 more nylon locking nuts on those rear M5 screws. And just as you did with the tensioner, do not over tighten these nylon locking nuts. You don't want to clamp the whole thing down such that your pulleys start binding. Once you're done tightening them down, you can check to make sure your pulleys aren't binding by manipulating the belt and just rolling it along those idlers and making sure that they're still spinning nice and free. The hole at the front of the pulley block has been threaded for an M4 thread, and you're going to take an M4 by 25 socket head cap screw and start to thread that in. You do not want it to be pressing on the tensioner at this point, so just thread it in the hole, and that will prepare you for later. The final pieces of this puzzle are these M4 T-nuts and these M4 by 14 socket head cap screws. They're just going to pass through these recessed holes here. A small portion of the thread will stick out the back, and you can thread on the M4 T-nuts. With the pulley block complete, we can now move on to the rear print bed support. And you can see here that I have some heated inserts in there. This was a piece that I was experimenting with. All of the pieces otherwise would normally just come with M4 threads into all of those holes. And so in those 2 large holes at the top, we're going to start by attaching our linear bearings. Now I went with the extra long linear bearings, but the regular length ones will work as long as you have the square flange. The bearings will just drop into place, and then you can use some M4 by 8 socket head cap screws to attach them. And because I only have 2 brass threaded inserts per bearing, I'm only going to be using 2 of the socket head cap screws. You can use all 4, of course. Now we need to grab a few pieces off of the original rear print bed support. The first thing we're going to get is the Z-stop bumper. And so you can simply unscrew that from that piece, and we're going to transfer it over to the new rear support. And so that hole there is where it goes. Again, these holes are threaded for M4 threads, so it will thread directly into this piece. In my case, I'm using the CR Touch, so I won't be needing that piece, and I'll remove it later, but for now, I just want to show you where it goes. Then we can remove the anti-backlash nut. I'm going to loosen off 2 of the screws up at the top, and then I'm going to unthread the entire lead screw by hand. I'm going to use my one hand to hold the bottom of the anti-backlash nut, the spring portion there, because it is under compression, and if you don't hold on to it, that thing will go flying across the room and you might lose the bottom half of it. Then you can completely remove the 2 screws from the top, and the entire anti-backlash nut will be free. Make sure you don't lose any of the small lock washers. There are a total of 4 of them. Now we're going to transfer the lead screw nut over to the new rear print bed support, and you're going to be reusing the hardware. So take an M3 screw, you're going to take one of the lock washers, slip it over top, and then slide that in through the slotted hole in the new rear print bed support. Then you can flip the whole assembly over, and you can place 2 more of the lock washers on the other side. Now this is the arrangement that Creality had from the factory. It's a little bit strange to me. I went ahead and just copied it. I don't think there's any real purpose to it. So if you guys decide not to sandwich those next 2 lock washers in there, I won't judge you. I don't really think they're doing anything. It's a little hard to get them in anyways. I'm using a set of tweezers here to do it. But once they're in, then you can just pop the top half of the lead screw nut in there, and you can start tightening them down. You do not want to completely tighten those screws down at this point though. You want to leave them a little bit loose so that that lead screw can shift around, and later on in the assembly we're going to tighten it down once we have our lead screw nut and the lead screw properly aligned. So leave it loose enough that it will still wobble around a little bit. And with the top of the lead screw inside of the rear print bed support, we can now put the bottom half of the lead screw nut in there along with that spring. If you'll notice, there are notches on these two pieces that should get aligned. So when you line up the spring and you push down on that bottom piece, align those notches so that they interlock, hold it with one finger, and then you can start threading in your lead screw. Eventually, when your finger releases the bottom half of the lead screw nut, if you've done it properly, that piece should not pop off and it should remain on the lead screw. Keep threading the lead screw in until that rear bed support is about 1/3 of the way down the lead screw. And if you guys are this deep into the video, maybe you should consider subscribing. Either you're really closely paying attention or you've fallen asleep. Either way, I'd love to have you as a new subscriber. Now, since we're already sitting at our workbench, we might as well do a little more pre-assembly. And so what we have here are 5 more 3D printed pieces. 4 are identical and 1 is different. This one here, we're going to start with some M4x8 socket head cap screws. You're going to screw them into those 2 center recessed counterbore holes. Don't tighten them all the way down, just get them in there so that the screws don't fall out. The outer 2 holes are going to receive M4x14 socket head cap screws, and on the threads sticking out from the back, you're going to thread on some M4 T-nuts. Now these 4 3D printed parts are identical. The way that I have them arranged here is that I have them arranged as mirror images of one another, left to right. And so when I place them down on the table, you'll see the front 2 will have the flanged bushing pressed in through the bottom, and the ones at the top will have the flanged bushing pressed in from the top. And then you'll see where the M4 T-nuts are placed. And I'm going to assemble one of these pieces here for you so you can see how it's assembled. But essentially I'm going to take that IGUS flanged bushing, I'm going to just pop it in with my finger. It's a very light press fit. Then we have M4x30 socket head cap screws that just pass through the pieces. And on the back side, there are 2 M4 T-nuts. And so again, when I go to place this part down on the table, you should take a very close look at how I've arranged them. They are mirror images of one another, left to right. And on the left-hand side, I have one piece with the flanged bushing on top, and then one with the flange on the bottom. And then I have the same thing going on the right-hand side. The flange goes on the bottom of one piece and then on the top of the other. Next, we're going to take care of the side print bed supports, and they are mirror images of one another. So I'm going to show the assembly of one, and I'm sure you'll be able to figure out the other side. If you have anti-backlash nuts, you're going to want to assemble them from this side here, so top side down, and that's going to allow the interlocking portion, the bottom half of the nut, to still interlock with this piece. If you flip it over the other way, it might not be able to fit through. In this video, again, I'm showing you the anti-backlash nuts right now. Later in the video, you'll see that I have switched over to regular brass lead screw nuts. And that's because either I ordered the wrong anti-backlash nuts with the wrong thread pitch, or somebody in China just put the wrong ones in the package. I haven't figured that out yet. But either way, I had to switch back to regular brass lead screw nuts, and those ones can get installed from the bottom side. Either way, they will both use 4 M3x10 socket head cap screws. Now I can attach the linear bearing. Again, these are the long style with the square flange. You can use the regular short linear bearings with the square flange. They're meant for 10mm shafts. Either one works perfectly fine, and they just attach with some M4x8 socket head cap screws. Back over at the printer, we can take our pulley block assembly, and you're going to grab the rear belt loop, and you're going to loop that around the pulley, and so you'll see that it slips over top of the coupler, and it's going to engage with those teeth on the pulley. And then you can take the entire pulley block and pull that back towards the rear extrusion, I'm going to use the 2 rear M4 T-nuts, and you're going to attach that to that rear extrusion. Just keep in mind here that you are tightening these bolts against plastic parts, and you can definitely get them tight, but you don't want to crack them and over tighten them. And now you can grab the top rear linear rod support piece. This is the one that you assembled that looks different than the other 4, and this is going to go at the top of your rear extrusion. There is no up or down side, so it doesn't matter which side in which way you put it. Just tighten those bolts down, again using the M4 T-nuts to secure this to the rear aluminum extrusion. And this piece here can go all the way to the top as far as it can go. You can butt it right up against that top plate. Next, we can install the rear print bed support and lead screw assembly. And so with the flanges on those bearings facing down, you can simply slip the lead screw in through the top hole and then down into the Z-axis coupler. Now you can take your 10mm linear rods. These are 400mm long. All 4 of the rods for this assembly will be the same length, so it doesn't matter which ones you grab. You're going to slide them in through the top holders, in through the linear bearings, and you'll see 2 pockets down in that bottom pulley block that will accept these linear rods. Make sure they are properly seated into the pulley block, and up at the top with those holders where they get clamped down, the tops of the rods should sit just about flush with the top of that holder bracket. And then you can tighten the bolts down that clamp the rods into place at the top. Looking at the top of your rear extrusion, this is very important. Make sure that your lead screw is not sticking out past the top of this plate. If it is, when you put the top of your printer back on, that lead screw will bind and your Z-axis will not be going anywhere. So if it is sticking out a little bit, you may have to either grind it down or file it down with a metal file. The reason for this is that underneath the Z coupler, we installed that 20-tooth pulley, and that pushes this whole assembly up a few millimeters. And in some cases, it pushes it up high enough to bind against that top plate. So please watch out for this. After that, you can tighten the top screw on your coupler, and that's going to lock your lead screw into place on the coupler. Now we can start the assembly on these side pillars, and you're going to be grabbing one of your side pillar linear rod holders. It's going to get attached to the inside face of the side pillar, but before we do that, we're going to put down one of these spacer blocks. Put the spacer block down in the orientation shown. The side pillar linear rod holder can sit directly on top of it, and then you can use the M4 T-nuts to attach it to the side pillar. The bolts that hold these mounts to the side pillar also are used to clamp down on the side linear rods. And so before you start tightening those bolts down, you're going to want to slip a linear rod through the middle of that bracket, and you're going to want to make sure it's seated all the way down inside of the pocket of that purple spacer. The purple spacer does 2 things. First, it makes sure that your linear rod holder is at the correct height off of the base of the machine. The second thing it does is it makes sure that your linear rod is also at the correct height off of the base of the machine. If the linear rod is sticking up too high, then it could come into contact with your print head. And once those bolts are tightened down, then you can go and grab your side print bed support, and you can slip that over top of the linear rod. And you're going to want that round indentation pointing towards the front of the machine, and that's going to provide clearance to your print bed adjustment knobs. If you've done everything correctly, this linear rod holder on the side pillar should be sitting completely flat against your spacer block. There should be no gaps, and they should not be seated at any sort of an angle. Now we'll put a rod holder at the top of the side pillar, and so you are going to take one of these rod holders, this time bushing side facing up, and you're going to slip that over top of the linear rod. And again, you are going to use the M4 T-nuts to secure this piece to the side extrusion. For now, you can just put this piece in any arbitrary position along that aluminum extrusion. Later on, we'll fix the position, and we're going to be using the lead screws to do that. Do the exact same thing on the other side pillar, And with those two side pillars done, you can carefully put the top of the machine back on top of the pillars. You can put the M5 socket head cap screws back into place, but do not tighten them down just yet. The order in which we are doing everything and tightening everything, I've carefully thought out to ensure that your printer goes back into place with the best alignment possible. And so with those top M5 screws loose, you can go around the two side pillars and loosen off all of those as well. You probably won't have to do the rear pillar. I left mine tight and my alignment ended up perfect at the end. So just do the side pillars and you should be fine. What this is going to do is it's going to allow your side pillars and your top half of your machine to align themselves properly when everything gets tightened down and once we get the print bed back in place. There's a little bit of wiggle room in this entire assembly and things will self-align again as I take you through this carefully thought out process. The two side lead screws can now get put into place. So from the top of the machine, just insert them through that top bracket. They will slide all the way down through your side print bed supports, through the lead screw nuts, and then through the bottom bracket, and they'll just sit themselves down on the base of the printer. Slightly loosen off the bolts at the side rod supports at the top of the machine, and then bring those down a little bit. What this is going to do is it's going to make sure that between the smooth rod and your lead screw, that bracket is perfectly aligned with those two so that neither of them are being bent and the lead screw is not going to bind. You can even move the side print bed support up and down a few times to make sure everything is aligned. The print bed is going back on the machine next, and you can pass it through the front opening of the machine and seat it on top of the rear print bed support. Use a few of the M4x8 socket head cap screws to thread the original print bed support bracket into the new rear print bed support bracket. And you do not want to completely tighten them down at this point. They should still be a little bit loose. And that's because you're going to want to tighten these bolts down at the back first. These are M4x14 socket head cap screws, and these guys here are going to pull the entire print bed into that rear bracket. That's going to get that seated properly first, and then you can tighten the ones down at the top. Looking at the bottom of your print bed, there are 4 M4 socket head cap screws that you're going to want to completely remove at this point. So I'm pointing to them here. Just remove them and don't worry, your print bed will not fall down. These are going to get replaced with some longer M4x14 socket head cap screws that are going to go through the side print bed supports and then into the original holes and thread into place. Keep in mind that the holes on these side print bed supports are slotted, and so that should give you enough wiggle room to get the holes lined up with the holes from the original print bed. This is also why we loosened off those M5 bolts holding down the side pillars to the base of the machine. If you need ever so slightly more wiggle room, you can move those side pillars around, and that's going to move these side support pieces, and you should be able to get everything aligned within the tolerances of the Creality machine. And at this point, these bolts should not be completely tightened down either. In a later step, we're going to be tightening them down once we get everything aligned. Now you can turn your rear lead screw by hand, or you can use the belt to turn the rear lead screw, and you're going to be pulling the entire print bed assembly down, not quite to the bottom, but just enough that you can still access those bolts that we just snugged up. First, tighten down the M5 bolts at the bottom of your side pillars, and this is going to lock those side pillars into place. Now you can tighten down those 4 M4 bolts holding the side print bed supports to the print bed. And with the print bed still in this very low position, you can take a look at the back of the machine, and we can tighten down those screws holding your rear lead screw nut into place. Now you can move the print bed to the top of the machine, and you can either use the belt to do this, or you can just take your hand and push up on the rear print bed support and force the whole thing up to the top of the machine. Make sure your print bed is not contacting the nozzle, and take a look at your rear bump stop. This should be contacting your rear limit switch before your nozzle contacts the print bed at this point. So there should still be a gap there. Now you can go around the top of your machine and tighten down all of the M5 socket head cap screws holding the top half of the printer to those pillars. Now we're going to take care of the rest of the belt system on the two side pillars of the machine. So you're going to need 2 of the nylon spacers, 1 of the lead screw collars, and 1 of the tooth pulleys. And this tooth pulley is going to be the one with the 8mm inner bore. And so you can see here that I took 1 of the nylon spacers, put it on top of that side bracket. Then I put the collar on top of that, and then the lead screw goes through both of those. On the bottom of the bracket, you're going to stack the nylon spacer on top of the tooth pulley, take your belt, wrap it around the pulley, and then get your lead screw to slip in through the entire assembly. Do the same thing on the other side of the machine as well. This is what it should look like. The belt might have a tiny little bit of tension on it, but everything still should be loose enough that those pulleys are going to skip teeth if you try and turn anything. Now I'm going to be using some metal bars here of equal length to rest the print bed on top of, but if you purchase a kit from me, I will include some 3D printed plastic bars to do the same job. You're going to place these down on the base of the printer, and then you're going to lower the print bed on top of these pieces. The metal print bed support plate is going to sit on top of all of these bars, and what this is going to do is it's going to ensure that that plate is squared up to the rest of the machine, and all of your bearings and linear rods will be squared up once we tighten everything down. Spin the tooth pulleys on the side into a position where you can easily access the grub screws on them. Most of these pulleys have 2 grub screws, so you want to be able to access both. Right now, because the belt is not tight and the teeth are skipping, you should be able to spin them and not move the print bed in doing this. Pull the tooth pulleys up towards the bottom of the bracket, squishing that nylon spacer into place in the process, and then you can tighten down the grub screws. At the same time, you're going to want to try and lift the lead screw off of the bottom of the printer so it's not rubbing against the metal base. It requires a little bit of coordination, but it is doable. Once you have both sides done, you can now tighten down the collars on top of those brackets. With all of those parts tight, the lead screw should not move up and down, and ensure that your print bed has not moved in the process. It should still be seated at all 4 points on those support bars. Remove the support bars, and now you can access the M4 socket head cap screw at the front of the pulley block. Threading this into the pulley block increases tension on the belt system. Just like any other belt on your 3D printer, you want the belts to be taut, but you do not want them to be over tightened to the point that you're stretching the belt. At the back of your machine, it's time to plug all of your cables back in and take care of any cable routing because we're almost ready to fire up the machine. Before turning the machine on, I'm going to be removing the Z-stop bumper because again, I'm using a CR Touch to home my machine. And so if you're using the CR Touch or the BL Touch, go ahead and make sure this was not installed. Turn the machine on, and you're going to want to preheat the print bed to about 55 or 60 degrees because we want to level this thing while it's hot. In the settings section of the machine, hit leveling and then press the home button over by the Z offset. This is going to home all axes of the printer. Make sure that as your print bed travels up, keep an eye on the print bed and the nozzle. Make sure your print bed does not crash into your nozzle. If you think it's going to crash, quickly turn your machine off and readjust your Z bump stop to make sure that it contacts the Z limit switch before that print bed crashes into the nozzle. Again, in my case, I'm using a CR Touch module, and so the CR Touch should be extended below the nozzle, and that should prevent the print bed from crashing into the nozzle. It's a little tough to get a good shot of this, but I have a small gap between the nozzle and the print bed, and if I look at all of my linear rods and bearings, none of them have bottomed out on the machine, so this is a good thing. There's still a little bit of travel left in those rods. Now what I like to do is set any sort of major Z offset value. And so I use the piece of paper method between the print bed and the nozzle, and I use the Z offset screen on the touch interface to make those adjustments. And so what this is going to do, it's going to bring the print bed up towards the nozzle, roughly a piece of paper's thickness away from that nozzle, and then you can get into the bed leveling with your adjustment knobs. Doing it this way instead of immediately going to the adjustment knobs ensures that you do not run out of travel on your adjustment knobs and springs. As I just showed you, there's a lot of travel left on the linear rods, and so you might as well take advantage of that instead of using up all of the travel in your adjustment knobs and springs. Now the Creality firmware is not all of that intuitive, so I like to hit the home button again on that previous Z offset screen to make sure it saves my Z offset. Then I'm going to get into the 4-point auxiliary leveling. So you saw those 4 points up on the screen there. And again, use the piece of paper method and now use your adjustment knobs to get your print bed leveled. And lastly, if you have the CR Touch or BL Touch, you can finally enable the auto bed leveling and get the auto bed leveling sensor to do its thing. Once that process is complete, you'll see all of the values come up for the 25 measured points on your print bed. It's also a good idea to check the maximum print travel on your printer now. I used the extra long linear bearings and I lost about 3 to 4 millimeters on my Z travel, which isn't really a big deal to me. If you use the standard length linear bearings, you shouldn't lose any. You might actually gain a few millimeters of print travel. But because I lost a few, my NG code had to be adjusted. Normally the NG code moves the print bed right down to the bottom at the end of a print. And so instead for me, I added just -10 to that portion here. So max print height -10 so it doesn't bottom out. Finally, I'm ready to get started with some test prints and make any last live adjustments necessary to the Z offset. In my case, I did not have to make any adjustments at all, and the initial setup was bang on. First layers came out extremely clean, and the addition of this spring steel build plate on this machine was amazing as well. Print after print after print on this machine has been extremely consistent with the first layer adhesion. The combination of the spring steel plate, the CR Touch, and this bed level support system is a fantastic combination. Prior to making this video, this design went through a few revisions and I extensively tested this setup. And I can confidently say that every time now I go to this printer and just press print, I can walk away and not have to think twice about coming back to a machine full of spaghetti. The machine continues to be very quiet. There are no squeaks or squeals within the motion system or the belt system, so I'm really happy with that. And even if you guys decide not to do this particular modification, I would still highly recommend a spring steel build plate on this printer. If you've never used one of these magnetic spring steel sheets on any of your printers, it makes print removal so easy. As soon as your print cools down, the PEI layer releases the print and it comes off with absolutely no fight. The original build plate on the Ender 7 wasn't too bad about releasing prints once they were cooled down, but any sort of force on that build plate originally wasn't a great idea because it was inherently so unstable with the cantilevered design. And so if you're looking for one of these magnetic build plates for the Ender 7, because those are currently kind of hard to find, you can head on over to my website, embracemaking.com, and I'll have those made available to you as well. We can now have a quick look at a few sample prints that came off of this machine, and the top layer here is exceptionally smooth. You can really almost see no print artifacts whatsoever on this entire print. I never print at the finest layer resolution because I'm just way too impatient, and so I always print as coarse as possible with a 0.4 millimeter nozzle, and the general rule of thumb there is about 0.3 millimeter layer heights. In this case, I'm using the Creality draft mode at 0.24 millimeters, so it's not quite as coarse as you could go, but at a 0.24 millimeter layer height, those are some really nice looking layer lines, which means that you can barely see them at all. On this entire print, the only small thing I could criticize was the presence of some very small wisps of plastic in a few spots. Other than that, that has nothing really to do with the Z axis at all, and that's probably just some temperature or retraction settings in the slicer for this particular material. Now these parts were printed with some slicer settings that were bumped up from the default settings ever so slightly, so I got 100 millimeter per second inner perimeters, 75 millimeter per second outer perimeters, and I turned the machine acceleration up to about 750 millimeters per second squared on each of the X and Y axes. Obviously those settings are not game changing by any means, but the point here is to prove that the machine in its sort of default settings or slightly faster than default settings can achieve a really nice quality print. The next steps here with this machine are to make sure that we can maintain this quality while we ramp up the speed and acceleration. And so essentially what you're seeing here are some benchmark prints. We want to continue to maintain this quality through the remainder of this project. And so that's it for this print bed support upgrade. And I think that it is a very worthwhile upgrade for you guys who are looking to push the Ender 7 to its limits, which I'm going to be doing in a future video. This design is much improved over the Creality cantilever design. And if you have an Ender 7 and you're looking for these exact parts to do this exact upgrade, check out the website I'm launching, embracemaking.com. I'll put a link in the video description down below where you can find these parts and a whole bunch of other 3D printing content that I have planned, including configuration files for machines, filaments, and all sorts of stuff. So I'm just launching that website. Be sure to check it out. Link in the video description. Thanks for watching and see you guys in another video.